meet, I'm a GMAT instructor with the Princeton Review, and this is going to be a video about a data sufficiency question. If you haven't watched our first video and you're not familiar with how data sufficiency questions work, please start with that one, where we go through the structure and what the answer choices mean. Okay, so if we're looking at a more advanced data sufficiency question than the last one. So here it says, if m is greater than 0, what is the value of m to the power of x divided by m to the power of y? So again, we're trying to answer, could we solve this? Do we have enough information to solve this? Now, the first thing I want to do is really break down what the question itself is asking, and we need to remember some of our exponent rules in order to do that. So if they're asking us to solve for m to the power of x divided by m to the power of y, because we're dealing with exponents that have the same base, for division we're actually going to want to subtract those exponents. So this is the same thing as m to the power of x minus y. And this is really helpful because it helps us know what we need in order to be able to say that something is sufficient. Well, the first thing we need would be the value of m, our base, in order to know what that's worth or what that's equivalent to. And then the second thing we would need to know is also the value of our exponent, which in this case is x minus y. Now, you might find yourself thinking, well, I need to know what x is and I need to know what y is, but we actually don't need those variables' individual values. We just need the difference between them, because that's what's going to determine the value of m to the power of x minus y. For example, if x is 4 and y is 2, we would have m squared, and that's the exact same thing we would have if x was, for example, 42 and y was 40. That would still give us m squared. So x and y individually don't matter. What we really care about is the difference between those two numbers. Okay, so now that we've thought through all that, we're ready to go to our two statements. So we start with statement number 1. Now, statement 1 says m is equal to 3. Well, that gives us the base. But the base alone is not helpful. That means we've got 3 to some power. But who knows what that power is? It could be 3 to the power of 2, 3 to the power of 20. We've got no information about the exponent there. So on its own, statement 1 would be insufficient. Now, if statement 1 alone is insufficient, we go to our answer choice options. A doesn't work, B does, C does not, C does rather, D does not, and E does. So we're looking only at the ones where statement 1 would be insufficient, and we're down to answer choice options B, C, or E. So now we look at statement 2 on its own, ignoring everything we knew in statement 1. Statement 2 says x is equal to y. Now you might be able to think, oh, well, there's no information about m, there's no way this could be enough information. But we actually want to investigate a little bit further and take this one and rearrange it. If I rearrange it so that both of my variables are on the same side of the equal sign, I can rewrite this as x minus y is equal to 0. Well, that's very interesting because that represents our exponent. And if you recall your exponent rules, you may remember that anything to the power of 0 is always equal to 1. So, while normally to calculate the value of an exponent, we do need to know both the base and the exponent, here, because it is that exceptional case of 0, we actually don't need to know the value of m, and we could solve it all. So, statement 2 actually gives us a sufficient amount of information. So we were down to B, C, or E, and we want one where statement 2 is sufficient. Well, if we look at B, that works. That's the one where statement 1 is insufficient, but statement 2 is sufficient. C and E both give us statement 2 is insufficient. So those wouldn't work. We would pick B, and we would be done and move on to the next question.